Hello, um, good afternoon, and welcome to this Oasys Gofer webinar. My name is Norbert Kovac. I'm a Senior Business Development Manager at Oasys. And as always, today we have a great session planned for you. But before we dive in, I just wanted to make sure you can hear me. So if you could please put into the chat box, where are you joining in from? That would be a great help. So let me just open the chat. Okay, so we have London, Berlin, Manchester, Bristol. Okay, cool. It looks like you can hear me. And yes, also looking at the attendees, I see lots of familiar names as well as new ones. So just for the benefit of anyone who's new to Oasys, Oasys stands for Over Systems, and we are Arab's in-house software developer. We build structural pedestrian simulation as well as geotechnical software. And as you know, today's topic is the exciting news we have for Gofer. And on that note, let's see who's going to be presenting. So today we have our geotechnical portfolio manager, Mark Skinner, senior geotechnical engineer, Matthew Brown, and two of our technical writers, Anya Hancock and Elizabeth Bailey. And just before I hand over to Mark, something for you to note, we are going to have a Q&A session at the end of the webinar. And for this, we would like to ask you to put in all your questions, anything that comes to mind, you can put it in. And as you can see on the screen, we have a Q&A button towards the top right part of your screen. So if you just click on that and put your questions into the compose box, that would be brilliant. And yes, that would be all from me. And I will hand you over to Mark Skinner. Mark, over to you.
Okay, thanks, Norbert. Hi, everyone. So let's just check I'm moving on to the right slide. Okay, so yes, thanks for everyone for joining. I'm going to start today's presentation, well, by saying what we're going to cover today. So I'm going to start off with a bit of a recap on Gofer, so what it is essentially, go through that a bit. Then we're going to hand over to Matt to show you what's coming soon, what's new in Gofer. That's the exciting part. Well, one of the exciting parts for today. And then we've got another section, equally as exciting, which is about how you get to know Gofer. How we've done a lot of work on that to try and make it easy to pick up, easy to get into. Going to wrap up with a small section on Giraffe, a newly launched product, just a quick glimpse of that, and then we'll have some questions. So hope that is interesting for you today. So without further ado, let's get into the recap. If I move to the next slide, there we are. Recap, what is Gofer? So what I tried to do with this slide is sort of visually show Gofer in 10 images. But essentially, it is our new general finite element analysis tool. It's a cloud piece of software, so it's in a browser. And we launched Gofer just over a year ago. It's our first new cloud product as Oasys, so a bit of a new start for us. And since that time, we've been improving it, and that's what we're really keen to show you all today. But really, we've got a family of products, some of which have been around, I think in some cases for up to 40 years, and they do certain jobs. This is a cloud product, and so it's a sort of new start for Oasys. By being in the cloud, you get access to modern development techniques, the power of cloud computing, and that's really exciting, and it unlocks a lot of things, both for us building the software and hopefully for you using it as well. A bit of a new way of using, consuming, and analyzing things in this software. So, as I say, it's web-based. You have an account to log in, and once you get in, you'll see that it's a sort of general finite element analysis tool. You can draw whatever you want to. It's free to draw things. We'll show you a bit of that later. And yeah, analyze how structures interact with soil, the behavior of soil, as you would expect. Now, we've kept Gofer. We're sort of aiming at the simpler end of the analysis spectrum, so it's not really complicated FEA models. So just bear that in mind as we go forward into the presentation. It's for your more sort of everyday task. That's where we want to aim Gofer, and we hope in this webinar you'll see that Gofer helps you achieve those everyday analysis tasks more easily, more quickly. And there we are. Okay, so on the next slide, I basically tried to sum Gofer up in one sentence. So there we are. Gofer combines the benefits of cloud software with geotechnical FEA capability to unlock exciting potential. And we'll get into that again later in the presentation, what that means, that potential. And we hope you'll see that coming through as we go through slides today. So a phrase you'll see in some of our literature, etc., that we put out is that this is a really FEA imagined, and there's three key aspects that I'm trying to show you on this slide that sort of feed into that. So over on the left there, ease of use, that's really important. With Gofer, we've built it from scratch, as I said, using modern design and software design and development methods. And really, it's all about making it both easy to use on a day-to-day basis, but also easy to learn to use. And we're really aware that when you come to a new piece of software, there's an investment to be made in learning to use it. So that's one aspect, actually getting the up to speed with how to use it. But then on a day-to-day basis, building those models, we want to make that as seamless as possible for you. So as an example, Gofer handles mesh refinement for you. So it automatically refines the mesh around things you've drawn, say structures or loads, which you may previously have had to do manually. Similarly, the restraints around the edge of the model, those are implemented automatically in Gofer. So that's a sort of just a couple of illustrations of how we hope sort of Gofer is taking care of stuff for you in the background. Overall, hopefully that saves you time on a day-to-day basis, getting those models built and run with as little effort as possible. That's where we want to see Gofer hitting. Okay, so in the middle then, the second theme, I suppose, is about leveraging cloud. So it's a website. You don't need to install anything on your machine, and your machine its capacity isn't taken up by running the analysis. You can have this open in a tab and head off and do something else. You can have multiple tabs open, and the calculation is done in the cloud. Now that's interesting of its own. So as I say, your machine's free. You don't need a powerful machine. Gofer's handling that. But it's more interesting when you get to the third pillar, which is more advanced analysis methods that can be unlocked by using that cloud power. So for example, Gofer has an API. You can have your own workflows, your own code, build Gofer into that, and you can queue up those analyses, and the cloud will obviously run through them, and then you just deal with the results. So what we're starting to see, what we want to get to with Gofer is that power, and I do come on to that, I think, in the next slide in a bit more detail. One thing I missed there on the middle, constantly evolving. So again, because it's a website, we can improve Gofer, we can add things to it, and they will just appear there. And that's really what we're going to show you later in the webinar today. Some new things that are being added shortly. Right. So in terms of fitting Gofer into your existing software portfolio, we're not trying to displace any existing tool with Gofer. We see it as a new tool that augments your toolbox. That's the left box there. It provides different tools. It is a different tool and allows you that extra capability. We're targeting, as I said, the more routine analysis tasks. And what we expect is that if you're currently using more expensive software, then hopefully this could take some of the sort of weight of that, potentially reducing software costs overall if you adjust the way that they're deployed. And as I said previously, Gofer's on a journey to leveraging cloud, and we really have some exciting plans in the future to allow you to access new ways of working by leveraging that power. So think optimizing problems. You can analyze problems many times with slight differences to parameters and see the effect of that parameter. That's where we want to get to with Gofer. And you can do that to some extent already with reading in your own code and using Gofer that way. So where is Gofer at the moment? Just as a recap, these are the key capability items, I suppose, that sort of frame Gofer. So we have linear elastic, more Coulomb soil models that will immediately pitch Gofer to you in terms of what it can do. It's a plane strain analysis tool. You can draw the things that you would expect to draw, in that sort of vein. So structures, loads. The structures can be joined with different connections, pins and springs. You can draw node links, joining two nodes with a elastic connection. Props we can add. We can do interfaces. Matt's going to cover that in a lot more detail shortly. And then we can do CFI analysis, steady state seepage. That's all in Gofer. Lastly, then, top right box there, sharing, again, because it's a web cloud-based product, you can just share a model with a link. It's quite an easy thing to do. We hope that helps in working collaboratively. Okay, so this is sort of an example, I suppose, of the sort of things you might be able to model in Gofer. It's obviously, it's down to your judgment whether you think it's suitable or not. These are things we think you might be able to model. So, things like piles, gravity retaining walls. We've got an anchor model there. The interfaces will help with that. So, yeah, we hope you'll see that that's where we are. All right. Now, last slide for me. I'm just going to mention again the user API. So what I'm showing you here is Gofer's Swagger. These are the endpoints that you can call from any sort of compatible software or coding language, coding environment. You can call these and you can manipulate Gofer models, send them for analysis. The results get returned to you, and you can then act based on those results. And by that, you can build logic around it. And essentially do whatever you want to the models and build them into your workflows, which is a key thing that we're keen to see Gofer used for. Okay, so that's a bit of a roundup, bit of a recap on Gofer. And I'm going to hand over to Matthew Brown now, to Matt, to talk about some new things. So over to you, Matt.
Great, thanks, Mark. Hopefully you can hear me okay. So as Mark said, I'm going to talk around a couple of really exciting new features which are either just released or about to be released, which I think will make our sort of day-to-day analysis as geotechnical engineers much more powerful, and it will really make Gofer a useful day-to-day tool. So the first of those are interfaces. So we might use interfaces to model the behavior of soil against structures in the ground. So perhaps we've got a sheet pile wall and we're concerned about the disturbance to the soil that installation of those piles might have. Interfaces is one way of modeling that in finite element analysis. The soil strength and stiffness are reduced along these interface elements by some reduction factor as specified by the user. In Gofer, that interfaces can be enabled by going to the strength tab in the material settings, and there's a tick box at the bottom, apply material reduction factor at interfaces, and then the user specified reduction factor. When that tick box is activated, Gofer will automatically insert those interface elements into the mesh around all structures. So there's no need for sort of manually tracing over the structures. It's all done automatically. and they are applied for all structures which are adjacent to soil clusters of this material type. So I've got a recorded demonstration, which I'll start here. So this is just a simple model. I've already drawn the geometry in here. So we've got a retaining structure in the middle, some sort of live load behind the wall, and then a soil cluster that we're going to excavate in front of the wall. All I've done so far is set up this geometry. I'm going to add the soil parameters, add the construction stages, analyze it, and look at the results within this demonstration. So first thing is to add some soil types. So I'm just going with a drained morculum, sort of typical sand material here. I've got a typical unit weight, typical stiffness values, typical strength values. Here at the bottom is where we would activate our interfaces. What I'm going to do is firstly run a model without the interfaces and then rerun it with the interfaces activated, so we can look at the difference in results. So that's our material defined. I'm then going into the construction stages and assigning that to all our clusters for our initial stage. So we will initialize the stresses like that. In our second stage, we'll install the wall. We can simply turn on the structure there. And then in our third stage, I will excavate in front of the wall, reset displacements, and activate the live load behind the wall. So that's our construction stages set up. Hit calculate and Gofer will go away. The server spins up and starts churning its way through our model. Give it a couple of seconds. There we are. So these are our displacement contours from that simple wall. We can see the wall's deflecting into the excavation, as we might expect. There's a slightly strange pattern of the soil sort of attaching itself to the wall behind, because we haven't got interface elements activated. And then if we drill down and look at the structure graphs, we've got a displacement of 13 millimeters or so in this particular example, and bending moments of 25 meters a meter, say. So then if we want to go and reanalyze with interface elements, we go back to our material, back to the strength tab, activate that tick box and put in whatever material factor we want. So I've gone with 2/3 for a sort of typical value for granular soil. No need to add the interfaces manually. Gofer does that. We go back to the results. Gofer knows that something's changed, and so lets us reanalyze those 3 construction stages. Again, the server spins up and churns through them. It's probably worth saying that I've gone for quite a coarse mesh in this example, just to make the runtime as quick as possible. Perhaps you'd have a finer mesh in reality. But just give it a couple of seconds, and then our results will be ready. And again, we can see the deflection contours. The soil behind the wall looks a little bit more sensible now. It's no longer attached to the wall because we've got the interface elements activated. And we see, as we might expect, a sort of slightly higher structural displacement and slightly higher bending moment profile throughout the wall, because we've got that reduction in strength and stiffness in those interface elements. So just a sort of simple example as to how you might set up and run a model with interface elements. Mark mentioned the API. After recording that demo, I loaded it up and was experimenting with sort of messing around with the interface factor and plotting out different values of bending moment and displacement. And it just goes to show how powerful a tool the API is, that you can push these analyses out to the cloud. It makes sensitivity checks suddenly very achievable and very easy to do. It doesn't tie up your computer to do as many analysis runs as you like. So the next feature that I'd like to talk about is the consolidation solver. So of course, the consolidation allows for excess pore pressures to be dissipated. So say you've got an undrained loading, undrained unloading, excess pore pressures are generated in the mesh. The consolidation solver allows for those to be dissipated. The stresses transfer from the groundwater to the soil, and therefore consolidation displacements to be calculated. Gofer has different options for consolidation. So under the calculation type, there's now a consolidation, or there will shortly be a consolidation button. And under there, we've got 3 different types. So a minimum excess pore water pressure, a degree of consolidation, and a defined end time. The way consolidation is set up in Gofer is that no other changes are permitted to the mesh or the loads during a consolidation stage. So you can't apply loads over the duration of a consolidation, for example. The idea is that you'd set them all up beforehand and then run the consolidation as a self-contained stage. Again, I've got another demonstration on this. I'll just hit play. So again, I've just set up sort of simple geometry for what might be a typical problem that we look at involving consolidation. So I might have a soft clay sort of foundation and then building a new embankment on top of it. Say this might be something I'm interested in, the consolidation duration and magnitude of settlements. So first things first, we're going to add some materials. I'm starting off with a drained clay type material with some typical parameters for unit weight, stiffness, strength. We don't need interfaces here, but the flow, the permeability is very important because, of course, that affects how long the consolidation takes. So I'm going to go with 1 × 10⁻⁸ meters a second here, which might be a typical permeability. I'm then going to clone that material and create an undrained equivalent to allow the excess pore pressures to be generated. Give it an undrained shear strength, and yeah, same permeability. The final material that I need is something to construct the embankment from itself. So some sort of fill. I'm just going to go with a linear elastic block here on the basis that all it's there for is to apply a load to our soft material when I'm interested in failure through it. Up the stiffness a little bit and make it a few orders of magnitude more permeable than the underlying clay. Okay, so all our materials are set now. We can start to add a groundwater table, of course. So I'm adding one at 2.5 meters below ground level. And then we can start to define our construction stages. So initially, we've got a drained clay foundation. I'm making sure to assign it to the groundwater table that I've just drawn. Then in our next stage, I will swap out that clay foundation for an undrained material. And then make sure that the pore water pressures are inherited from the previous stage there. Okay, so now we are ready to load. That undrained material will generate excess pore pressures. So I'm going to activate that our new embankment sat on top. Make sure that my pore pressures are inherited from the previous stage. Okay, so now we've built the embankment, we've generated those excess pore pressures. I'm going to change the foundation soil back to drained in order to then run the consolidation. The excess pore pressures are locked in at this stage, so they'll be inherited through into our drained cluster. And then our final stage, we can run a consolidation. I'm going to go with the minimum excess pore pressure, so essentially allow it to fully consolidate. So again, I've got quite a coarse mesh here just to make sure it runs in a reasonable time for the demonstration. Server's going through and running through all these stages. We can start to look at them as it's running the later ones. So this is our undrained displacement from construction of that embankment. You can see we've got a constant volume material at the bottom, so we get a bit of heave to the side. Looking at pore pressures, I'm just going to flick the signs over so we can see we're generating excess pore pressures under the embankment on the left there, whereas out on the right it's more like our greenfield version. And then long-term pore pressures are all back to how we expect, and our consolidation settlements here. So we've got values of, I don't know, 57 millimeters, whatever they happen to be. Perhaps this is a road we're building on top of the embankment. Perhaps we don't want that much settlement after putting on the rigid finishes. So we can look at introducing some sort of hold period in our construction sequence here. So that's what I'm doing. Perhaps if we allow consolidation just for 30 days, say, let the thing settle during construction and then put on our rigid finishes. Perhaps we'd like to know the settlements that we can sort of design out that way. So adding in 2 new consolidation stages here. The second one we'll consolidate it down to 1 kPa excess pore pressure. Gofer realizes that we've changed the final 2 stages, but we don't need to rerun the first 4. So we hit run again. And now in that first 30-day periods, we can sort of get rid of 35 mil in this particular example of settlement. And then we might put our rigid finishes on and only have to worry about 20 mil, say. So these are, just kind of general examples as to how we might use these various different consolidation calculation types in our day-to-day work as geotechnical engineers. Of course, we have compared Gofer to other popular commercial offerings for geotechnical finite element analysis. These graphs and displacements show one such comparison, again, an embankment on soft ground. The graph at the top shows that Gofer matches very favourably in terms of settlement and dissipation of excess pore pressures with time. And the contours at the bottom show not only that the magnitudes, the maximum values are the same, but also the distribution of movements across the meshes are very, very similar between the 2 options. So things like this give us confidence that the software is doing what we think it's doing and giving us the right answer. In terms of other new bits, Mark mentioned that Gofer's cloud-based, and so it's very easy to sort of incrementally improve things as we go along. A couple of such improvements, the way groundwater in excavations, or at least above soil clusters, is modelled has been improved. Previously, this needed sort of a manual load applying, but that's no longer the case. Gofer will do that automatically. And also sample points. So this allows you to highlight a node on the mesh and then plot out sort of stage displacements of that node across the duration of your model. Another useful tool, especially with consolidation, to plot sort of time dependency outputs. And now it's time to hand over to Anya and Elizabeth.
Thanks, Matthew. Okay, so hi everyone and good afternoon. My name is Anya Hancock and I'm joined by my technical writing colleague today, Elizabeth Bailey. We both work on Gofer, and between us we produce all of the documentation, support materials and UI text. So in this section of the webinar, we'll show you what support is available, including primary and supplemental support materials, how to navigate them, and how we've expanded our support materials to complement a range of learning styles. So Gofer definitely has a very distinctive style, and from the very beginning it was clear to us that any text or support materials should feel like a seamless extension of this. A little playful, but ultimately clear, straightforward, and above all, very easy to follow. So the images here from left to right show all of the support material types available in Gofer. We have our step-by-step documentation with separate theory manual, the example models, video tutorials, and news articles. And all of these materials support a variety of learning styles. So maybe you prefer to get stuck in and start using the interface straight away. In that case, you'll want to head straight to the documentation. But if demos are your thing, then our tutorials will break down Gofer's tools and interface into helpful short videos, while process-driven learning styles will find our example models helpful. Whatever your style, mix and match any of these materials at different stages as and when you need them. So the Gofer documentation is split into 2 separate sections. There's a step-by-step how-to guide which breaks up each part of the interface and provides instructions on how to carry out tasks in Gofer. and a separate theory section which presents technical details of the Gofer solver. You can access the documentation once logged into Gofer via the help icon in the top right corner of the interface. The how-to documentation follows a typical Gofer workflow, beginning with setting up the basic parameters for your model, right through to applying more complex modeling conditions, and finally running an analysis. So the image here shows the how-to section of the docs alongside a model in Gofer. There are 4 ways to navigate the documentation. You can explore topics via the left-hand menu, find specific entries through the right-hand menu, search by keyword using the search bar in the top right, or simply move chronologically through entries at the bottom of each page. In the example above, you can see how easy it is to refer to relevant sections while working on your models directly, thanks to annotations, icons, and GIFs that supplement and illustrate complex concepts. Once logged into Gofer, you'll find the Learn tab beneath My Models on the left-hand menu, and hopefully there's a video about to play now if I timed it correctly. So this is our embedded library of video tutorials. And each of these short, step-by-step videos are designed to help you get the most from Gofer, from first node to final results. They highlight different sections of the interface. They show you where to access Gofer's tools and features, and how to complete fundamental tasks, all in real time. You can pause, replay, and consult, all at your leisure. So I'm going to hand over to Elizabeth now to talk through the rest.
So the News tab is one of Gofer's newest features in terms of the support materials. And here you'll find articles on Gofer's adventures outside of the cloud, including details of webinars, such as this one, conferences, and key milestones. If you're looking for inspiration, you'll also find details of our latest features here too. This is a place where you can stay informed and engaged with all the exciting developments happening within the Gofer community. Finally, our example models contain both synthetic and real-world case studies. These models evaluate the effectiveness of Gofer solutions by applying them to various geotechnical scenarios, such as flexible cantilever retaining walls or cut-off dams. Each story includes a comparison of results between Gofer and at least one other competitor, geotechnical finite element analysis software. And that's what you can find here in these tiles is the option to select. So it comes from the side menu. The option to select pops up with the whole story with all the details. There's also the model you can take a look at. And you don't have to take our word for it, because in each of these scenarios, we give you not only the visual comparison of the results, but all of the parameters and data you need to model the scenario for yourself in the product of your choice. So if you like to jump off of, and start with something and not have a blank screen, this is a great way for you to begin. You can click on the button to clone the model and have a go yourself based on what we've already set up for you. And our library of tutorials and examples continue to expand to support your understanding and use of Gofer. To coincide with interfaces and consolidation capabilities, new tutorials and example models are also in development. Mark?
Thanks, Elizabeth. Thanks, Sonia. Fantastic. Okay, I'm going to do a bit of a summary of Gofer now. And what I'm actually going to do is just do a quick walkthrough of Gofer itself. That involves me stopping sharing this screen and sharing another one, which is I always find tricky. So let's try to do that now. Share this one. Hopefully that's come through. This is Gofer. So when you log in, this is what you see. And as I say, I'm just going to do a very quick run through of a bit of a walkthrough, walk or run, whichever, to show you around Gofer essentially. So yeah, this is where you land when you log in to Gofer. This is my models, so a list of the models that you or I in this case have built. I'll just start by creating a new model, and what we have here is a wizard that allows you to quickly create, hopefully, the sort of extents of your model. So the intention is that you start with the width and height and number of layers that you want in your model. So let's start that, create new model, and then Gofer does exactly that and gives you some layers form the overall width. So having created a new model, Gofer has taken me into well, it's opened that model obviously, and we have 4 tabs on the left here. The first one is an overview, which is the details I've just entered, so you can change those if you need to. Next one is all about drawing, so it's geometry, and then you can enter materials as well in this tab. So just to touch on drawing, we mentioned earlier that we want to Gofer to be really easy to use, and we hope that comes through again here. But you start with your layers, and then you start to add your detail. So when you draw something, whatever it is, that thing appears in front of the existing model. So you can see I've drawn a rectangle there, but I can manipulate it. I can snap it to the grid or to existing objects to get it where I want to be, or I can type in coordinates to carefully position things. When I'm happy with that position, I hit apply, and Gofer will snap that into the model. So you can see it's cut the blocks, soil blocks, and it's added a new piece of soil where that shape I drew was outside the original extents of the model. So by doing that repeatedly, we can do that with, this is a free form version, so you can draw whatever shape you like. There we go, close that shape and hit apply. So by doing that, you should be able to build up fairly complex geometry fairly quickly. You can click into nodes and edit their positions and drag them around as well once they're built. So I can move that if I want to. So hopefully that's nice and easy. Obviously, this is not a viable piece of soil. We've got an underhang there, or it depends on the parameters you put in, but let's continue anyway. Next thing you might start to draw is your loads, your structures. So we do that here. We can add line and point loads and displacements. We can add moments, but only to structures when we've got some of those. So here's a line load. You position it. Again, that's in front of the model. When I'm happy, hit done. I can enter the magnitude of the load over here, and that's saved. Everything's saved automatically because it's in the cloud. See, it's just catching up there. And the same applies to things like structures. So select a structure, position it on the model. There we go. Oh, let's just drag that. It needs to hit an edge. There we go. Apply. So there's my new structure. And again, I can enter some parameters. My browser's got previous values I've entered in here, so it's nice and quick just to put those in, change the name if I want to. The slight difference with structures is that it's actually cut those soil blocks as well. So you can see I can now click them. Okay, so that's pretty much how you draw things. I won't spend too much time drawing lots of detail. Just show you the options here. So you can draw a phreatic surface, horizontal groundwater surface, and then the point and flow controls you'd need for steady state seepage analyses. They can all be added in this view. And then you can draw cross sections. They're not mathematically part of the model, but they are able to be positioned on the model. And that's, as you'd expect, a line along which results will be sampled once they've run. And then, as Matt just presented, sample points coming soon into Gofer. That would be the same sort of thing. You just click a node and say where it wants to be. I'll just show you while I'm here as well. Any node, at any node, you can control the refinement of the mesh. So it's automatic unless you change it. When it's if the refinement element size is set to 0, Gofer will adjust it automatically. If you put a value in, it will then try and make the elements that size at that node and refine accordingly. Okay, I'm just going to show you quickly materials. So you can enter materials here. Matt showed you this briefly earlier. I won't directly enter a material now, but I will import a material from a different model just to show you that that's possible as well. So let's grab a couple of materials. There we go, done. So obviously I could go in and edit those if I wanted. Right, that's all about drawing. Next tab, configuring. Now, this is where you set your stages, your analysis stages. I won't do that in this model because obviously it's not really a legitimate model. I'll jump into one in another tab, which is a little bit more likely looking, with some stages already set up. So this, again, we've focused on trying to make this as easy as possible. If I select some components of Gofer, you'll see the panel on the right has responded to my selection. Whatever I've selected, I'm then able to control over here. So I can turn things on and off, I can set materials, and I can assign groundwater or tell it to retain the previous stages groundwater pressures in this panel here. And that's really how you do it in terms of configuring stages. You can obviously change the settings as well, so that the calculation type, you select that in the stage settings as you go through, reset displacements, that sort of thing. If I click through, you'll see different things turning on and off as we go through, but that's really how that works. Lastly then, on results. So as Matt said, results are available as soon as the stage is finished. You know, other stages can still be running. That's not a problem. And really, it's as you'd expect. Let's just turn the grids off for clarity. So you've got all the results you'd expect. Your stresses, effective stress, total stress. You've got your stage and total displacements and their different components. Strains as well. And if you do a steady state seepage analysis, you'll have the additional results from that available. You can deform the mesh, and you can display any result at the same time. Quite like ability to show stress results on a deformed mesh. If I switch that off, you'll see the cross section there. That's the dashed line that's been specified. So with that cross section, you can open a graph and see the sampled results along that section. You can turn on an envelope to see how those results vary through the stages. You can download those as a CSV. It goes straight into your downloads folder for onward use. And lastly, quickly just show you the structural results as well. Get a graph of those, same sort of thing as the cross section. So that's a sort of lightning tour of a Gofer model, I guess. Just to round up, Anya and Ellie showed you these tabs, but I'll show you them again just here. So example models are all available. Videos in our Learn tab, showing you how to do things. And news. Here we go. There's today's webinar announced in the news, and so we'll use the news to announce new features, that sort of thing. Upcoming webinars when we're at conferences. That's where Gofer is. And you get to the docs that Anya and others have showed you through the menu on the top right here. There we go. Okay, that's a whistle-stop tour of Gofer. I will jump back into the presentation now. What Gofer's about. So yes, we're hoping it's come across that it's nice and easy to use and easy to learn to use. We've really tried to put a lot of effort into that design to help in that case. It's focused on the sort of everyday analysis. We're not looking to try and displace existing tools that do really complicated things. This is about the more routine tasks, and we hope that means that Gofer is more accessible to more people that otherwise might be put off using FE. Gofer is cloud-based, so we're leveraging that cloud compute, and there's some really exciting things you can do with that, particularly if you add it into wider workflows. And again, that's an extension of what you might be able to do already. Fourth point there, I guess I've covered that already, but yeah, Gofer can power your automation because we have that API, user API. And as you've seen, we've got new things continuing. Continuing to be added to Gofer, I should say. So yeah, consolidation coming pretty soon. Okay, so just before I hand back to Norbert for some questions, just wanted to show a few slides on something totally different. So this is a little welcome to Oasys Giraffe, our second cloud product that we launched very recently. Giraffe is an integration for OpenGround, the data geotechnical information management tool from Sequent. And really, so this slide here is showing you where giraffe sits in a common workflow, the site characterization workflow. So you imagine you're going out to site, you're getting data, you put it in OpenGround or to store it, to manipulate it. And where giraffe sits is the graphing of that data. It's an integration for OpenGround. It works seamlessly with OpenGround. It connects to OpenGround, gets your data, and plots it up on standard geotechnical graphs. We've got a library of geotechnical graphs inside Giraffe. You can also do your own custom graphs as well. Obviously, you then may what we think is that you then use those graphs to interpret your soils and rocks to get those parameters to go into reports. That's where we sit in terms of Giraffe. I've got another very short video here which shows you Giraffe. You see it looks quite similar to Gofer, but this is Giraffe's graph library. So these are all the geotech graphs that Giraffe knows how to plot. So it knows what data to query from OpenGround. And if I search, just grab a PSD graph, you can hover over the graph card there. It tells you what it's going to query to build that graph. Hit create. This is recorded in real time, so it's just grabbed the data from OpenGround, plotted it up. Gonna pop in a figure number there in case I want to put this in a report. Now the thing is that this is a website, it's interactive, so you can hopefully start to interact with your data there. So I'm hovering over specific geologies and seeing the data flash up on the graph, and we hope that that's something of interest. That started again, so I'll go on to the next slide. There's Giraffe. If you're keen to hear more, then check out our website. We've got more information on there. Okay, that is me. I'm going to pass back to Norbert for questions. Yeah.
Brilliant. Thank you so much to all of our presenters. We do have quite a few questions, so I'm just going to straight dive in. How do the CFI strength reduction results compare with slope limit equilibrium analyses? I see quite a few of these questions have already been answered, so I'm just going to call on, well, probably Carol for this time.
Yeah, sure. Yeah, the CFI analysis is pretty consistent with slope limit equilibrium. If the failure surface is similar, in LE analysis, you basically tell it where you expect the failure surface, and it will calculate that factor of safety. So in Gofer, that failure surface is not sort of predefined in any way. So if you've got an approximately circular, for example, failure surface, then the results would match fairly well. If you've got something like a very hard stratum that's making it more non-circular, or a combination of part circular and non-circular, then you may get a different result, but it's generally regarded as a more realistic result. One of our sample models is looking at exactly that and comparing it with a published paper example from a few years ago, so that's worth a look if anyone's interested in that area.
Brilliant. I'm sure quite a few attendees will be interested in that. Next question, do you plan to add more advanced material models to Gofer? Who would like to take that question?
Shall I try that one? It's
go for it. Yeah.
In a word, yes, we would love to. We're thinking about which ones essentially to do. So consolidation coming very soon, and then we'll be moving on to think about what we do next in terms of adding soil models. Definitely an aspiration.
Brilliant. Then the next question is, have you considered support for Eurocode 7?
I can take this one again.
Sure.
This is quite interesting because Eurocode 7 has various analysis, methods which have changed in the different editions of it, and probably the most straightforward to implement in FE analysis is factoring of the material strength parameters. We haven't done that yet, but obviously users can do that manually effectively. We would it would be something we could add in the future if it's of interest, to be able to compare unfactored analyses with the factored case, that sort of thing. I think that's definitely something we could put on a list for consideration for future development. Yeah.
Yes, that's also something that these webinars are very useful for. And every time when you see something that you think would be helpful to add into our software, you can let us know. Okay, so the next question is Gofer able to carry out a coupled analysis? Carol, should I bounce back to you? I see you have already replied to that.
Yeah.
You're very popular
So
today, yes.
Yeah, so the consolidation analysis that we've implemented isn't fully coupled. It's a kind of stepwise procedure which calculates the dissipated pore pressures and then the displacement, and then sort of goes back again and makes sure everything's in equilibrium before it completes that time step. So this is quite an established process. We're using a that can be a very slow process as well. So we've implemented an acceleration method that was part of Professor Scott Sloan's work from Australia, again, a number of years ago, and that's the method so far. There's a possibility that we'll add fully coupled in the future, but yes, this was a good intermediate step on the way.
Brilliant. The next question, Mark, maybe you can answer this one. Do you have to reanalyze to get the results along a cross-section?
No, you don't. And you can draw the cross-section after Gofer has run. So just jump back into the draw tab and draw it, and then jump back into results, and that cross-section will be there, and you can sample the results along that line.
That's great. And the next question is, can a soil material be replaced with another material, i.e. tunnel lining during an analysis, so that the lining starts at zero stresses and does not inherit the previous soil stresses? Who's going to be brave to take that one?
I think it's probably me again. Yeah, there is an option to set the existing strains and displacements to zero in a stage, in any stage of analysis, but that resets across the whole model. So often that will, that's something people do, for example, when they're inserting structures, that sort of thing. If that doesn't cover this specific case, then if you can send more details in, we can check back with our solver team and see whether they think that would be doable in the existing solver setup. But I think I've only really seen that applied to the whole model in previous work.
It might be worth adding, even if even if you were to reset the displacements, the stresses would not be reset, so they'll be inherited.
That's true. Yes, it's strains and displacements that we reset. Yeah.
Okay. The next question is it possible to do a seismic analysis?
So I type the response to this. No, not currently. Gofer is aimed at a more sort of routine, everyday analysis for now, rather than dynamic seismic analysis.
Okay, thank you, Matt. Next question is, can I still access the tutorial videos and example models on the 14-day trial? Yes, so during the trial, you can access all the material and basically everything that you have within the Gofer support section, but also quite a few of our YouTube video of the videos we do have on YouTube, so you can access them from there as well. Anya, I see you have replied to that question. Is there anything else you would add to that?
No, just to reiterate what you've said, it's the full functionality of everything. So as you've seen in the demos today, using the models in real time alongside the support, nothing changes in the trial period. You can do all of that just the same. You just get a reminder towards the end of the 14 days asking you whether you'd like to sign up. So yeah, you should be able to get the full functionality of everything.
Brilliant. Next question is the groundwater profile only horizontal? Can it be inclined or more complex? See, there are 2 comments on that. So Matthew and Carol.
So to apply a groundwater profile is horizontal only. The way to set up more sophisticated profiles and gradients and so on is to run seepage analysis from within Gofer.
Brilliant. Is there anything else you would like to add, Carol?
No, that I think I've said pretty much the same thing. One thing is if there are existing excess pore pressures, they'll be carried across that new seepage analysis, if you like, into the next stage that, well, into the next stage which can deal with excess pore pressures. So you won't lose them, if you like.
Brilliant. Next question is it possible to draw using coordinates input, i.e. running commands to quickly draw out the shape we want, rather than using the drawing tool or perhaps importing CAD or DXF file into the model?
So I can grab that one if that's good.
Go for it, Mark.
So yes, you can import DXFs. It deals with the straight lines only. So no curves, but we'll just ignore those and any text you have in the drawing. Now, coordinate input, you can manually change the coordinates in Gofer, but to do it, the only other way to do it is through the API. So you can change whatever you like via the API, but obviously you need to use code to do that. But you can change the coordinates, no problem at all. It's just a bit more of an involved process than doing it in Gofer itself. Yep.
Brilliant. Last 2 questions. Is it possible to do Power Foundation design using this software?
So remember that it's plane strain only. So depending on the sort of types of geometry you're thinking of, it may or may not be suitable. There's no option for an axisymmetric sort of analysis around a single pile, for example.
However, we do have software specifically developed for pile analysis and design. So if you can get in touch with us, I can help you out with that question. And the last question, what type of underground structures we can design using this software?
That's a very, very open question, isn't it? And we said earlier, anything you're confident we can draw. So we've got those plate structures. We've got interfaces. You can join those structures. So you may be comfortable doing retained excavations. A box structure. Any type of wall going into the page, I suppose. Anything you want to add, Matt, Carol?
Yeah, no, not really. Yeah, lots of options, I think.
Okay, brilliant. So I think that was the last question we had. Unless there are any other questions, I think we can wrap it up there right on time. Well done for everyone. Thank you for everyone for attending this webinar. Thank you for our brilliant speakers. That was definitely a large amount of information. So make sure you sit down, process it. As you might already know, we do have free trials available for Gofer. So you can just go to our website and you can apply there for a license or for a trial, or you can directly contact us at oasys@arup.com. Brilliant. So with that, I'm going to say thank you again and have a nice afternoon. Bye for now.
Bye, everyone.